Today we'll be working on the first 6 weeks review, numbers 13 through 24. So the first one says, which of the numbers below is not a multiple of 15? So we're looking for the one that is not a multiple of 15. So to find multiples of 15, one way we can find out if it's a multiple, we can add 15 several times, and if any of these is our sum, then they are a multiple of 15. So I know that 15, and if we add 15 more, that would give us 30. 5 plus 5 is 10. Regroup the 1. 1 plus 1 plus 1 is 30. So I know 30 is a multiple of 15. So this one cannot be the answer because we're looking for the one that is not a multiple of 15. So if I have 30 and I add 15, this is 5. 3 plus 1 is 4. So 45 is a multiple of 15. So they can't be my answer. I'm looking for the one that is not a multiple of 15. So if I have 45 and I add 15 more, 5 plus 5 is 10. 1 plus 4 is 5, plus 1 more is 6. So 60 is a multiple of 15. So that one cannot be my answer because we're looking for the one that is not a multiple of 15. So if I have 15, this gives me 5, that gives me 7, 75. My answer would be 85, but I'm double checking. So I go 75 plus 15. This gives me 10. This is 8 plus 1 more is 9. So 90. I already passed 85. So I know that 85 is not a multiple of 15. So my answer would be B. All right, the second one says, Sandra was asked to divide the base 10 blocks shown into 4 groups. Which digit would be in the tens place in Sandra's final quotient? So we have to divide that into 4 groups. So I can make the 4 groups. 1, 2, 3, 4. So we start dividing. Do I have enough tens to put 1 into each group? I do. So I put this 10 here, this 10 here, this 10 here, and this 10 here. So I look again at the remaining. Do I have enough to make another group of 10? So I know I have that one goes there, that one goes here, this one goes here, and that one goes here. So I know I'm going to have 2 in each group, 2 tens in each group. And they're asking us which digit would be in the tens place in Sandra's final quotient. So how many tens am I going to have? I'm going to have 2 tens. So whatever I'm going to get is going to be 20 something because I know I'm going to have 2 tens. So more than likely is going to be J, 2. I can finish dividing. So I know I can't divide that there anymore. So I'm going to break it up into the ones place. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I can put this one here, this one here, this one here, that one goes here. So I still have enough to put 4 more, 1 more in each one. I still have 4, so that means I can still put 1 more in each one. So that means I have 23 in each group. So my answer would be 23. So if I look at the tens place, there is a 2 in the tens place. So my answer would be J. All right, so the next one said Nathan served his family 4 out of 6 pieces of pie. Which model shows the fractional part of the pie he served? So we know we have 4 out of 6. That means that my total is 6 pieces. So I go 1, 2, 3, 4, 5, 6, 7, 8. So this is 8 pieces. This is 4 out of 8. So that one cannot be my answer. Then I go to this one. 1, 2, 3, 4, 5. This is 4 out of 5 because there's 4 shaded out of 5. So that can't be it because we're looking for 4 out of 6. 4 out of 6. So now I go here. I have 1, 2, 3, 4, 5, 6. I have 1, 2, 3, 4 that are shaded. So this is 4 out of 6. So this one might be our answer. I think this is our answer, but we'll check it here. We have 1, 2, 3, 4, 5, 6. So this is 6 total pieces, but only 3 are shaded. These are 3, 6. So that one cannot be it. So 4 out of 6 is C, because there's 6 total pieces and 4 are shaded. So my answer would be C. All right, number 16. Mike solved the multiplication problem below using an area model. Complete the model to find the product. Write the equation with the final product. So we have to complete this model. All right, so on an area model, they took a number, they put 47, and they broke it up into two parts, the tens and the ones. 40, that's 4 tens, and 7 ones, so 47. So these are the tens place, that's the ones place. They're multiplying by a single digit, which is 7. So on this area right here, I'll multiply that 7 times that 40. So I go 40 times 7 equals. All right, so whenever I'm multiplying by a 10, which has a 0 at the end, I multiply the first digit times that digit. So I go 4 times 7. That's 28. 7, 14, 21, 28. So I can write the 28. And then I bring down that 0. This 0, I just bring it and put it at the end. So that would be 240. Now this is the ones place. This is the area for the ones place. So I'm going to multiply anything in this area. So I have a 7 up here, and then I have a 7 over here. So I go 7 times 7 equals, I know 7 times 7 is 49. So now I have two partial product. I have this product of 40 times 7, and I have the product of 7 times 7. So what I need to do is, if I add my partial products, I should get my final product. So I have 280 plus 49. That should give me my final product. So I got 0 plus 9 is 9. 8 plus 4, that's 12. Regroup the 1. And then we add, where 1 plus 2 is 3. So my final product is 329. It says write an equation with the final product. This is actually my equation with the final product. Or I can write it this way, 280. Let's write it like this, 47 times 7 equals 329. All right, 17. Freddy sketched an array to represent a multiplication problem as shown. What is the final product for this multiplication problem? Record your answer in the boxes below, then fill in the bubbles. Be sure to use the correct place value. All right, so when we have an area model or an array, we look for the rows first. So how many rows are there? 1, 2, 3, 4, 5, 6. There's 6 rows. How many are in each row? So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. There's 6 rows of 18. So we can multiply it. We can write it 18 times 6. That's going to give us our total. So 6 times 8 is 48. Put the 8, regroup the 4. Regroup those 4 tens. So it goes 6 times 1 is 6, plus 4 more, that's 10. 6, 7, 8, 9, 10. So there's 108 little squares there. So our area is 108. So now we have to put these in our place value chart. So remember, these are the ones, the tens, and hundreds. These are my decimals. These are tenths and the hundredths. My number is a whole number. It does not have a decimal. So that means I will not use these two right here. So the 8 is in the ones place, the 0 is in the tens place, and the 1 is in the hundreds place. So I shade in 100, no tens, and 8 ones. And that's it. So my answer would be 108. And there's no decimal, so I will leave those blank. Right, number 18 says, which geometric term best describes a figure formed by two rays with the same vertex? All right, so we have to draw two rays. Remember, rays has an endpoint, and then it goes on forever in the other direction. So it has an endpoint and goes on forever in another direction. So these are two rays that have the same vertex. This is the same vertex right here. So what do we call this? It's not a triangle. It's not a polygon. Polygon is any figure with three sides or three or more sides. It's a closed figure. This only has two, so no, that is an angle. Line segments has a beginning, has an end, and it's just one line. So my answer would be an angle. Number 19. A figure is shown below. Which two lines do not appear to be perpendicular? So we see that word not in uppercase, so do not appear to be perpendicular. So we got to know, remember what perpendicular is. Perpendicular are lines that make a right angle. So if it makes a right angle, those are perpendicular lines. If it doesn't make a right angle, those are not perpendicular lines. So we go here, line segment CD and DE. So we look CD and DE. So we're looking at this right here. So an easy way to see if that is a right angle, because it looks like a right angle, is to use a post-it note. If the corner fits perfectly there, we know that that is a right angle. So this is a right angle. So that one is a perpendicular line, but we're looking for one that is not a perpendicular line. So I know A cannot be my answer because he has a right angle. So let's look at B. Line segments DE, so here's DE, and EF, or FE. So we're looking at this line and this line. So it makes an angle there. That doesn't look to be a right angle. It looks more like an obtuse angle, but I can check. So I put the post-it note there, and it doesn't fit perfectly. So it fits with this bottom line, but it doesn't fit to this line. It's greater than a 90 degrees. So this one could be my answer because this is an obtuse angle right here. So it's not perpendicular. I'm going to put a question mark on this one because that one might be my answer. So let's look at line segment AG and line segment FG. So it's this one right here. So if it has a right angle, then it can't be my answer. Again, I put my post-it note, and it's exactly a right angle. It fits perfectly with this line and that line. So this is a right angle. That means it's a perpendicular line. So this one cannot be my answer. And then line segment AB and BC. So we're looking at this angle right here. Again, I put my post-it note right there, and I can see that it is a right angle. So these are perpendicular lines. That means it cannot be my answer. So my answer is B, because that one makes an obtuse angle. All right, number 20. Maurice drew an angle larger than a right angle. Then he made it into a triangle by drawing a third side. What kind of triangle did Maurice draw? So he drew an angle first, larger than a right angle. So we know he drew an obtuse angle because obtuse angles are greater than 90 degrees, greater than a right angle. And then he connected them. And what kind of triangle did he make? This is acute. This is acute. But this one up here is obtuse. All right, so any angle with one obtuse, any triangle with one obtuse angle is an obtuse triangle. (21) 4 lines are shown below. Which two lines appear to be perpendicular? Again, perpendicular lines make right angles. So we have to find the ones that make right angles on it. All right, so it's line A and D. So here's line D. Here's line A. So here I should have a right angle if that's a perpendicular line. So again, I'm going to use my sticky note. And that is not a right angle, that's an acute angle. And up here, that is not a right angle, that's an obtuse angle. Because my sticky note doesn't fit perfectly in there. So I know this one cannot be my answer. So the next one is line B and line D. This is line B, this is line D. So we're looking at this right here. So again, if it makes 4 right angles, that would be my answer. So I have a right angle right there. That works. I have a right angle right here. Definitely works. This one is a right angle. And now this up here is a right angle. So all of them are right angles. So these lines are perpendicular. So my answer would be B. I can check line B and line C. Those are obtuse and these are acute. So that one can't be my answer. And then line C and D. Line C and line D. So we're looking here. Again, 2 obtuse and 2 acute. They're intersecting lines, not perpendicular lines. All right. Number 22. Team made a polygon with only 1 pair of parallel sides and 2 obtuse angles. Which term describes Tim's polygon? Alright, so he made a polygon with 1 pair of parallel sides and 2 obtuse angles. Alright, so he has a parallelogram because there are parallel sides and larger angles. Right, so we can try parallelogram. Parallelogram. Try it like that. So it says he made a polygon with 1 pair of parallel sides. So this line and this side are 1 pair of parallel sides. This line and this line are 2 pairs of parallel sides. And 2 obtuse angles. It does have 2 obtuse angles. It has an obtuse angle here and here. But it has 2 pairs of parallel sides. So parallelogram cannot be my answer. Alright, so the next one is a rhombus because there are 4 equal sides and 4 obtuse angles. So if I make a rhombus, alright, so on a rhombus, we have 2 pairs of parallel sides and 2 acute angles and 2 obtuse angles. So this only has 1 pair of parallel sides. So rhombus is not going to be my answer. Then this is a trapezoid because there is a pair of parallel sides and 2 obtuse angles. But let's make a trapezoid. So there's a trapezoid. It has 1 pair of parallel sides. This top line and this bottom line are parallel. These 2 lines are not parallel. So it does have only 1 pair of parallel sides. And does it have 2 obtuse angles? It has 1 obtuse angle here and 1 right here. Yes, it does, because this is 2 acute angles down here. So this one could be my answer. The next one is a triangle because there are parallel sides. And so if we make a triangle, I don't have any parallel sides. There's none that are parallel, so J cannot be my answer. My answer is H, the trapezoid. 23. Which triangle appears to be a right triangle? So we have to figure out if it has a right angle on it. Remember, right angles make perfect corners. We can check with our post-it note. So if I go to triangle A, I know these 2 are acute, but maybe this one is a right angle. So yep, this is a right angle. So this one is a right triangle. In B, all of them are acute angles. So this is an acute triangle. C, these 2 are acute. That one might be a right triangle, but when I put the sticky note, it's not because this line does not match that line. So this is actually an acute triangle. And these 2 are acute. That third one appears to be an obtuse triangle. I can check with my post-it note. And yes, it's an obtuse triangle because it's greater than that right angle. So my answer is A. A is a right triangle. 24. The frequency table shows the favorite sport of some girls. The table is missing the information for the number of girls who chose softball. So we're missing softball. The number of girls who chose softball is half the number of girls who chose gymnastics. How many girls chose gymnastics and softball as their favorite sport? All right, so we want to know how many girls had softball. So we know that the girls that chose softball was half the girls that chose gymnastics. So I need half of 36. So when we're looking for half, we divide by 2. So I can go 36 divide by 2. So I look at the tens. Can I divide the 3 by 2? Yes. That gives me 1. I can make one group of 2 if I have 3 tens. So then I multiply. 1 times 2 is 2. I subtract. It gives me 1. I bring down the 6. Now how many groups of 2 can I make with 16? 2, 4, 6, 8, 10, 12, 14, 16. I can make 8 groups. So 8 times 2 is 16. I subtract. It gives me 0. That means softball had 16. And so I can make 18, sorry, not 16. So this is 18. So I could go 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. That's 10. 1, 2, 3, 4, 5. That's 15, 16, 17, 18. All right, so my question is, how many girls chose gymnastics and softball as their favorite sport? Sketch to solve. So we want to know gymnastics and softball as their favorite sport. So that means I have to combine gymnastics and softball. So I have 18 plus 36. And that should give me my answer. So 8 plus 6 is 14. So 4, we group the 1. 1 plus 1 is 2, plus 3 more is 5. So 54. My answer would be H. 54 girls chose gymnastics and softball.